All right, for the next few lessons, we're going to be concerned with testing using many different types of series for convergence. We will not be particularly concerned with finding the sums, but just does it converge or not converge. So we're going to look at some tests where you can determine that. One of those tests that we're going to look at today is the integral test, and this can be used to test for either convergence or divergence. It only works if the expression can be integrated if you replace the n with an x. So for example, this would be a series right here, the sum of 1 over n squared. If we replaced n with x, it'd be 1 over x squared, and we can integrate that one. So that would be a good problem where we could use the integral test to solve. Here's another example. Find the sum of 1 over n factorial. Well, here, if we try to do this integral, we can't integrate x factorial. We don't have a way of finding that antiderivative. So integral tests would not be appropriate to use on this one. We're going to find some other tests later where you could figure one like this out. Why does the integral test work? Well, here's how it kind of looks. If you have a series where the graph is approaching 0, as you can see here, this blue graph is decreasing, and it looks like the limit as you go to infinity is going to equal 0, which means it might converge. Remember, just because the limit as n goes to infinity of this equals 0, that doesn't determine that it's going to converge or diverge. It just tells us that it might be. So what we want to do then is if you replace that, the curve there with an integral, and we solve that, and we find out that this diverges, well, that tells us then if the sum of all these rectangles that we have here, if the blue one converges, then this bigger graph where you got all these rectangles, that would also then have to diverge, because anything bigger than that graph is going to diverge. Similar, if we have another decreasing graph where the limit equals 0, and we find out that this converges, then this smaller graph of our rectangles, if we add all these up, if something's smaller than this, anything smaller than this graph should also then converge. So that's how the integral test works to determine convergence. So summarizing all that, if you have a continuous positive decreasing function, and now that's important, then this series right here is going to be convergent if and only if the integral is also convergent. So if the integral converges, that's the same as the series, then that's convergent. If you find out that the series or the integral is divergent, that means your series is divergent. So whatever the result of the integral is going to be the result of the series.